Hello and very good morning, dear students. Now, after completing the binomial theorem, we are heading to the next topic, that is sequences and series. Okay, so we are starting this chapter by a small introduction. Okay, as you heard about sequences and series many a times. Okay, but now in this chapter we will be dealing with basically the three series, that is arithmetic series or arithmetic progression, geometric progression, and harmonic progression, if it is there in the syllabus. So arithmetic and geometric progressions, we have seen this in the 10th class. Now we will be seeing some more challenging questions. Okay, and one last topic, which is special series, which has been exempted in the latest IAC syllabus 2021, so we won't be touching that. Okay, uh, okay, so starting with sequences have many important applications in several spheres of human activities. When a collection of objects is arranged in a definite order such that it has an identified first member, second member, third member, and so on, we say that the listed collection is in a sequence. Say, for example, a amount of money in a fixed deposit in a bank over a number of years occur a sequence. Depreciated value of certain commodities occurs in a sequence. Population of bacteria at different times forms a sequence. So such type of uh, sequences, or the collection which is in the determined way or determined number, that is the sequence. So we can define that a sequence is a succession of numbers arranged in a definite order and formed according to a definite law. Then the element of the sequence are called its terms, or the whole of a case is a sequence. Okay, or according to our book, a set of numbers arranged in a definite order according to some definite rule or like by law, this is called a sequence. Now there can be finite and infinite both sequences. Okay, so for the infinite case we won't be seeing. Okay, so for the finite case only we will be seeing. Now, sequence or progression, they both are same at a time. If a term of a sequence can be described by an explicit formula, then that sequence is called a progression. Say, for example, I'm writing one progression here: 1, 1, 2, 3, then 5, then 8, 13. Okay, so this is a progression. Which progression I'll tell you. See, if I'm taking the first member as 1 and second member as 1. So 1 plus 1 is what? 2. 2 plus 1 is what? 3. 3 plus 2 is what? 5. 5 plus 3 is 8. 8 plus 5, 13, and so on. By adding the preceding two numbers, that is, this is a kind of progression, and this is called a Fibonacci sequence. As in the 10th class, you would have made a Java program on such type of pattern, that is Fibonacci pattern or Fibonacci series. Okay, so this is how the Fibonacci works. Okay, now coming to the next, that is series. If the terms of a sequence are connected by any sign, that is plus sign, we get a series. Okay, so this is the definition of series. Now let me tell you. See, the first exercise 10.1, that is based on a very basic level questions. Okay, which we can which you can do, examples, try to understand. The main thing or the main question or the main turn will be our arithmetic progression. From arithmetic progression, I mean to say, so we'll be focusing from the arithmetic progression. So 10.1, just have a look. Okay, if you don't get any question, you can surely ask to me. Okay, I'm excluding, I'm skipping this 10.1 because there's nothing in it which you can not understand. I'm directly starting from the important exercise, that is arithmetic progression. Okay, so arithmetic progression, what it is? A sequence is called an arithmetic progression if and only if the difference of any term from its preceding term is constant. That means the common difference remains the same throughout the series. So, for example, if I'm writing 3, 6, 9, 12, 15, and so on. So, is it a arithmetic progression? By your some knowledge of arithmetic progression, you can say that yes, this is a arithmetic progression. And why? Because there is a common difference of 3 between the two numbers, two consecutive numbers, all right? That is 6 minus 3 is 3, 9 minus 6 is 3, 12 minus 9 is 3, 15 minus 12 is 3. That is the reason it is called a arithmetic progression. Okay, and we know that what is the general term of an AP, or we can say the last term of an AP. Okay, that is an is equal to a plus n minus 1 into t. This formula we have seen in the 10th class. If we want to find any term or last term, we used to use this formula. An is equal to a plus n minus 1 into d, where a is the first term, n is the number of terms, d is the common difference. Okay, so please remember this thing. One more thing, if three numbers a, b, c are in AP, if a, b and c are in AP, then what can we say? B minus a has to be equal to c minus b, because common difference should be same. So b minus a should be equal to c minus b. From here I'm taking minus of b this side, so b plus b is equal to a plus c. 2b is equal to a plus c, or b is equal to a plus c divided by 2. So if you want to find the middle term, a plus c divided by 2, if you'll do, you'll get the b. Okay, so keep in mind this thing. Then comes the, okay, so the for this exercise, which one, 10.2, this is purely based on the general this formula, a plus n minus 1 into d. So let's do some questions of it. Okay, so the question is, we need to find the 10th term of the sequence, and the sequence is root 3, root 12, root 27, and root 48. Okay, so how will you verify that this is a arithmetic progression? So first, let us just simplify this sequence. Root 3 is written as it is. Root 12, can this root 12 be written as 2 root 3? Okay, this can be written as 3 root 3, 4 root 3, and so on. So 2 root 3 minus root 3, I'll get root 3. Okay, 3 root 3 minus 2 times of root 3, root 3. 4 times of root 3 minus 3 times of root 3, root 3 will get. So yes, this is in arithmetic progression, and we need to find the 10th term, that is a10 we need to find. Using the formula an, that is a plus n minus 1 into d, that is 10th term we need to find. So n is equal to 10. From here, just find a is what, root 3, the first member of this sequence, that is a, root 3, and d is what, 2 root 3 minus root 3 will get root 3. So d is also what, root 3. So in place of a, we are writing root 3 bracket 10 minus 1 into root 3, that is root 3 plus, this is what, 9 into root 3. Okay, root 3 plus 9 root 3 will get 10 root 3, because this is 9 times and this is 1 time. On adding, we'll get 10 root 3. So this is the answer. So such type of easy questions are there there at the starting. Okay, just do. Okay, let us take another question. Okay, so here is the question, that Sn is equal to 2n square plus 3n. We need to show that the sequence is in AP, and with that we need to find first term and the 100th term. Okay, so for proving this sequence to be in AP, we must require what, that is a and common difference. Okay, So you know how to deal with such type of questions. See, you have the sum of the numbers up to n, that is 2n square plus 3n. Okay, if I ask you what is Sn minus 1, this is the pattern which is given to us, which is a sum of n terms. Now if I ask you what is the sum of n minus 1 terms, which is a one preceding number of n minus 1, so you will tell me 2, in place of n will put n minus 1. So let's see what happens. 3 times of n minus 1, this will be 3n minus 3, multiply 2 inside, so 2n square plus 2 minus 3n, sorry, minus 2n plus 3n minus 3. So we'll finally get what? 2n square minus n minus 1. Okay, and we know that if I subtract Sn minus Sn minus 1, okay, you have sum up to n, and we have found the sum up to n minus 1. If I subtract this minus this, I'll get this part, or we can say this is an only, or we can understand like if you have s1 and s2, and if I subtract, we'll get a. Okay, we'll get we'll get what, we'll get d from that one. Okay, we'll get a term. Why? See, for example, if you have 3, 6 and 9, okay, and what will be s1? It will be 3. What will be s2? This will be 9. What will be s3? It will be 18, because s1, or this is nothing but a1. S2 means 3 plus 6 9, and S3 is 3 plus 6 plus 9, which is 18. So if I do uh, S3 minus S2, that is 18 minus 9, we are getting 9. Okay, which is nothing but our A2 term. Okay, so from here one pattern we can make, that an, to find an, that is the nth term, we can find by Sn minus Sn minus 1. Okay, provided n should be greater than 1 in this case. Okay, so what will be Sn? What is our Sn? 2n square plus 3n minus Sn minus 1 is 2n square minus n minus 1. Okay, when we'll take minus inside, so it will be minus, this will be plus, this will be plus. Okay, this is cancelled, 3n plus this will give you 4n plus 1. So an, we got the pattern as 4n plus 1. By this we can easily find the a1, that is the first term, and the second term, and by that we can easily find d, right? So what will be a1? 4 into 1 plus 1, which is 5. Okay, and what will be a2? This will be 4 into 2 plus 1, this is 9. So from here can we find d? A2 minus a1, 9 minus 5, 4. So the common difference is 4, and the first term is what? 5. Now from here we can easily find the 100th term also. Okay, I hope you have understood this question. Okay, let us do one more question. So this question: which term of the series 4 plus 0 minus 4 minus 8 and so on is 392? Minus of 392. So in this series, uh, at which position or at which term you will get minus of 392? So from here we can find a, this is 4, and what is the common difference? 0 minus 4 minus 4. Let us consider minus of 392 as any term, okay, or just consider an is equal to minus of 392. Okay, an is a plus n minus 1 into d, which is 392. A is what? 4, and we need to find, and this is minus of 4. Okay, so 4, this minus and this plus will become minus, and multiply 4 inside, so it will be 4n. Okay, and this okay, to avoid the confusion, let us do 4 minus of 4n plus 4. Okay, that is what I was trying to say. 4 plus 4 is what? 8. Okay, this is minus. Okay, minus 4n is equal to minus 392. Take minus of term here and 4n that side, add it, you'll get 400 equal to 4n, n is equal to 100. So at 100th position you will get minus of 392. Okay, so similarly please do up to 10 or 11 10th question. Okay, and do the examples also. Okay, up to here you do, and from there in the next lecture I'll take some more questions of this. Okay, and then we'll head to the next exercise. Okay, so that's it for today, dear students. Do practice. Okay, go through the examples very thoroughly, they'll help you. And for the 10.1 you can go through the examples. Okay, uh, and if possible, if you could do, then do the questions too. Okay, that's it for today. Thank you so much. Have a nice day. Bye bye.